In this case study analysis is an important method in scientific research. Offer relation of specific instance or application to understand broader concept and evaluate the effectiveness of particular technique. In the context of environmental monitoring, especially water quality assessment, case study enable valuable insight into the real-world performance or detection technologies. Spectroscopic technique, particularly ultraviolet visible or UV-VIS and near-infrared NIR spectroscopy have emerged as useful tools for detecting a range of pollutants, including organic matter, heavy metals, microbial contaminants, and emerging pollutants. This case study aims to explore the application of UV-VIS and NIR spectroscopy in water quality detection. It evaluates the underlying principle, technical implementation, and practical outcomes of using this method in different environmental scenarios. By analyzing this specific case, we aim to highlight the advantage, limitation, and future potential of spectroscopic-based approach in sustainable water.
Sampling process. Sampling is a statistical method used to select a subset of or individual or items from a larger group to conduct analysis and draw conclusion from the data collected. It is an important method in conducting research or data analysis, allowing researchers to draw inference or data analysis without conducting any individual study. For this case study followed by extraction activity and the preparing the samples suitable for UVV analysis.
For the concentration calibration, stock solutions were prepared by dissolving the dry powder of the dye into distilled water or methanol. This was successively diluted to cover a calibration range of 1.8 to 9.0 mg per liter. All of the solutions were passed through 0.45 micron filters to remove any particle that may interfere with the absorbance. Wastewater samples were also filtered and pH adjusted to 10 using sodium hydroxide. The process stabilizes the matrix of the dye and yields precise measurement. The research was carried out using a UV spectrophotometer with wavelength scanned from 200 to 800 nanometers. Each dye's lambda max or wavelength for maximum absorbance was identified. The concentrations that were known were employed to construct a calibration curve, and the unknown sample concentrations were determined by comparing their absorbance against the curve.
Journal 1. Simultaneous determination of dispersed dye textile wastewater. This study used UV-V spectrophotometry and multivariate statistical analysis (PCR and PLS) to measure the level of 6 types of dyes in textile industrial wastewater. Samples were taken after dyeing by pH adjustment and solid phase extraction (SPE), with absorption spectra recorded between 200 to 800 nanometer. The PLS model show very high prediction accuracy R2 more than 0.99 and was more efficient than HPLC. This method was proven to be rapid and effective for monitoring industrial water quality. Journal 2. Investigation of natural dyes in historical Coptic textile. This paper used UV-vis technique in conjunction with HPLC and mass spectrophotometry (MS) to identify natural dyes in archaeological Coptic textile. UV-vis detect dye absorption peaks, while MS confirm the structure using ESI and APCI ionization. This technique is effective in identifying dyes such as carminic acid, luteinolene, alizarin, and purpurine with wavelength of 200 to 700 nanometer, supporting high precision, quantitative and qualitative analysis.
Journal 3. Water quality detection using UV-vis and NIR. This study used the Lambert-Beer law and near-infrared NIR spectroscopy to analyze water directly without chemical reagents. This method is suitable for rapid field monitoring and is combined with machine learning such as PLSR and SVM to improve prediction accuracy. The wavelength range of 200 until 760 nanometer is used to detect water quality parameters such as COD, heavy metals, microorganisms, and emerging pollutions.
UV-VIS spectroscopy identifies seed type of dispersed dyes. Multi-beam PLS technique achieve high accuracy R² more than 0.99, more effective and cost-efficient than traditional HPLC, suitable for real-time industrial water quality monitoring.
Next, in another study, UV-vis was combined with HPLC and mass spectrometry (MS) to identify natural dyes in archaeological textiles. Absorption spectra of compounds like carminic acid and alizarin were successfully measured, confirming the power of UV-vis as a qualitative tool for analyzing complex organic molecules.
And the last point of data or result analysis is, first, UV-vis and NIR spectroscopy used to predict water quality indices. Applied Lambert-Beer law and ML models PLSR FVM. And third is detected COD, heavy metals, and microbes without reagent. And the last one is non-invasive and eco-friendly method, wavelength 200 until 760 nm.
Alright, we just reached the end of our presentation. So the conclusion part, through these three journals, it is shown that UV-vis and NIR spectroscopy techniques are very good method for analyzing pollutants in the air, especially textile wastewater. This technique use multivariate statistics such as PLS and PCR to analyze various data sets, saving time and money and increasing accuracy through the use of machine learning. This method has great potential for widespread use in fields related to sustainable water management and environmental pollution control. Thank you for watching this video.